Imagine a world where an ocean of molten rock breaks against a pitch-black shoreline of hardened lava. A place where a seething, hot and swollen star hangs perpetually over the shoreline. A place where night never falls. Imagine a world where the rocks glow in luminescent shades of pink, blue, and green under a madly spinning burned-out star. A planet where auroras continually dance across the starry sky in eerily vibrant colors. Imagine a world where hazy orange clouds of fog swirl over a landscape of rolling hills of tar. A place where black volcanoes spew out diamonds across the vast terrain. These may all sound like the products of a wildly creative imagination, but they're not. Scientists now believe that places like these, and places even more incredible, may actually exist throughout the universe. Now, armed with the latest scientific methods of detection, we are combing the skies, looking for planets that may be like Earth. And what we are discovering are places so strange and exotic that they defy the imagination. So let us take a look then at some of these truly extreme planets. Since the mid-1990s, we've discovered hundreds of planets circling around neighboring stars. The nearest is only 10 light-years away. The farthest lies halfway across our galaxy. By using powerful new telescopes, innovative observational techniques, and the relentless curiosity of astronomers, we have finally entered a realm that once only existed in the pages of science fiction. Stars with planets are scattered across the sky in every direction you look. Within just 30 light-years of Earth, astronomers estimate there could be as many as 10,000 extrasolar planets, or planets beyond our solar system. Our Milky Way galaxy conceivably holds trillions of planets, and, similarly, among the several 100 billion other galaxies inhabiting our universe, there could be infinitely more. With countless worlds existing throughout space, the inevitable question emerges: how many of these may be like Earth? Small, rocky bodies with atmospheres, seas, mountains, and rivers, and perhaps even life. We haven't found any yet, but our search has just barely begun. And the best place to start such a search is at the beginning. The very first extrasolar planet discovered is the size of Jupiter, but orbits within a mere 5 million miles of its star, 51 Pegasi. To remain so precariously close, the planet orbits quickly. Its year is just 4 Earth days long. Astronomers do not think a planet this size could have been born so close to its star. It must have traveled to its present location. They now believe that close encounters between big planets and smaller ones can rob energy from the larger planets, causing them to spiral inward. Astronomers also did not expect to find planets in very elliptical orbits, since most planets in our solar system have quite circular paths. The star Epsilon Eridani, however, has a Jupiter-sized planet whose oval-like orbit swings in as close as Venus is to our Sun and as far out as Earth. Planet formation, scientists have found, can be even more chaotic than we thought. The idea that the universe could be full of planets is not new. Nearly 2,400 years ago, the Greek philosopher Democritus held that the universe was infinite. Therefore, he concluded, other inhabited planets like Earth could exist or have existed elsewhere in time and space. Over the last 100 years, exploring strange new worlds and seeking out new life and new civilizations has become a staple in science fiction. But it has only been within the last several years that astronomers have had the technology to detect these elusive extrasolar planets. An Earth-like planet orbiting a nearby star would be 1/10,000,000th the brightness of its parent star. Trying to see one is more difficult than trying to see a ladybug crawling on the rim of a car's headlight over a mile away. To get around this problem, astronomers have developed a variety of techniques for indirectly detecting the presence of a star's orbiting planets. The ultimate goal of these planet hunters was to directly photograph a planet orbiting a nearby star. It is an aspiration that scientists have fulfilled. One of the nearest known extrasolar planets orbits the star Epsilon Eridani, which is only 10 light-years away. This planet was discovered by its gravitational tug on the star. The planet loops along in a very elliptical orbit that periodically brings it very close to Epsilon Eridani. When this happens, the planet will be at its brightest and could be barely observable with Earth's largest telescopes. It is much tougher for telescopes to directly photograph Earth-like planets. They are much fainter than Jupiter-sized planets and are swallowed in the glare of their parent stars. Plans are already underway for larger space telescopes, especially those with instruments to precisely block out the tiny disk of a star. With its glare removed, one or more of the star's accompanying planets would pop into view. The farther we go in our search, the more our discoveries push the boundaries of what could be thought of as Earth-like planets. The real universe is turning out to be even more imaginative in its creation of extrasolar worlds than we first thought, and in some cases, it seems to be downright capricious. For every star like our Sun in the galaxy, there are nearly 10 times as many stars that are smaller and cooler. These are the red dwarfs, and more planets are being found that orbit them. This planet, for example, is in close proximity to its Sun, The red dwarf's tidal forces have slowed down its spin until one side is permanently facing its star, in much the same way that one side of our moon always faces the Earth. It is a world perpetually shrouded in darkness on one side and continually lit on the other. The planet's thick atmosphere carries warm air from the hot side to the cold side, thus moderating its temperature. Even if the atmosphere on this planet were thinner, it might still be able to support life at its terminator, the thin boundary that transitions between day and night. In this narrow twilight zone, the surface could actually have temperatures in a habitable range. Here, we see spectacular stellar flares shooting above the horizon and creating eerie light shows that dance across the sky. The majority of the extrasolar planets we have discovered so far are Jupiter-sized worlds that have migrated very close to their stars. It is also possible that such gravitational interactions could propel distant planets of rock and ice inward into a much smaller orbit around a star. Here, a large icy world has spiraled in towards its sun. The ice has melted and created a water world. Blanketed under a thick, moist atmosphere, this world is far more resistant to cosmic cataclysms, such as asteroid impacts and radiation from nearby exploding stars. Stars have a lot of elbow room in our corner of the galaxy. The nearest star to our Sun, Alpha Centauri, is nearly 4.5 light-years, or over 24 trillion miles away. But for stars living deep inside a globular star cluster, it is more like being inside a crowded subway car. Close encounters between stars are common here. In this near collision, a planet is torn from the gravitational clutch of its parent star and hurled into interstellar space. The surface of this orphaned planet soon freezes solid as it hurtles away from its birthplace. Eventually, even the atmosphere freezes out, coating the surface with a bright white frost. But a planet like this, the size of Earth, carries along its own internal furnace into the frigid depths of interstellar space. Heat percolating from its molten interior could keep small regions of the planet's surface warm. As the planet travels on into eternal night, such concepts as days and years, seasons and solstices would soon have no meaning. At least half of the stars in our galaxy travel with companion stars. Could planets survive in these multiple star systems? If the two stars in a binary system are very close together, a planet could easily orbit about their common center of gravity. From its surface, we could then witness the phenomenon of two stars in the sky, one rising in the morning shortly after the other. In other binary systems, the stars are separated by billions of miles. This makes it possible for planets to independently orbit around each star. The nearest star to our Sun is actually a multiple star system which includes the pair Alpha Centauri A and B. These two stars are as far apart from each other as the Sun is from Uranus. Imagine if civilizations independently arose on Earth-like planets orbiting their respective stars in a binary system. Even with our current technology, it might actually be possible for them to visit each other. And communications between the two stars would be measured in hours rather than years. We expect Earth-like planets to be made mostly of silicates, compounds of silicon and oxygen that combine together as the planets condensed around their sun. However, they don't necessarily have to be. They could be made of compounds like graphite and carbides, materials which would then form planets made of carbon. The surface of this carbon planet is tar black and can withstand very high temperatures. The whole planet is truly an asphalt jungle with an orange, smoggy atmosphere. Its core is rich in crystallized carbon, better known as diamonds. Towering pitch volcanoes spew these huge, rough diamonds across this planet. As the sensitivity of our instruments improves, astronomers are discovering ever smaller planets, though nothing as small as Earth yet. Among the smallest is a world 15 times the mass of Earth, orbiting a nearby yellow star called 55 Cancri. This rocky world is massive. Nearly 3 times the diameter of Earth, it has 10 times the surface area. With a large molten interior heated by radioactive elements, it is a planet with a lot of trapped energy that is desperately trying to escape. Molten rock pours from immense shallow volcanic calderas, creeping across the planet like a monster stretching its tentacles. This is a desolate landscape covered with oozing pancake domes, lava channels, sinuous rills, and rolling volcanic plains. The surface is so hot and plastic that it can't even support mountains or volcanoes of any real size. This planet also orbits incredibly close to its parent star, requiring only 3 days to complete one orbit. It circles 55 Cancri at a distance of only 3.5 million miles, giving it a surface temperature of over 1,700 degrees Fahrenheit. Face-locked to its star, the surface of the starward side of this super-Earth is completely molten. The gas giant extrasolar planets could have many satellites. In our own solar system, Jupiter has dozens of moons. This implies the possibility that many Earth-like worlds in the galaxy may be moons rather than actual planets. Astronomers using the Hubble Space Telescope have estimated there are at least 6 billion gas giant planets like Jupiter in our own galaxy. This suggests there could be tens of billions of large moons orbiting these giants. It's conceivable there could even be Earth-sized moons that orbit gas giant planets more massive than Jupiter. We've already found gas giant planets that orbit near or within the parent star's habitable zone, that region around a star where liquid water can exist. Once again, we visit Epsilon Eridani, holding one of the nearest known extrasolar planets to our solar system. The giant planet is in a looping 9-year-long eccentric orbit, one that carries it as close to the star as Earth's orbit around our own sun, and then as far out as Jupiter's. Because of the planet's elliptical orbit, any moons would experience long, cold winters and brief, hot summers. However, heat could be retained on an Earth-sized moon if it had geothermal activity and a thick carbon dioxide atmosphere trapping the star's radiation. The first extrasolar planets ever discovered turned up in a very unusual place. They orbit a neutron star, the crushed, burned-out core of a massive sun. These strange planets were found by their slight gravitational tug on the neutron star. The whirling neutron star sends out precise machine gun-like bursts of radio energy, similar to the beam of a rotating lighthouse beacon. The timing of these bursts fluctuates slightly because of the gravitational pull of 3 small rocky planets. Rocks on the surfaces of these planets may fluoresce under the intense glow of ultraviolet light from the seething hot neutron star. This pulsar is evidence that a massive star exploded as a supernova. Among the most powerful events in the universe, a supernova would vaporize any planets orbiting the doomed star. So how did these planets get there? Some of the debris from that explosion probably settled into a disk orbiting the shrunken remains of the star. Planets would have congealed inside the disk, just as they do in disks around newborn stars. NASA's Spitzer Space Telescope has spotted the warm glow from a dusty disk around another neutron star. The disk orbits at a distance of about 1 million miles and probably contains enough material to make 10 Earth-sized planets. For the first time in human history, we are actually finding Earth-like planets orbiting other stars. NASA's Kepler Observatory is spending several years gazing intently at approximately 100,000 stars in the direction of the constellation Cygnus. Kepler will be able to detect if any of the stars temporarily dim due to an Earth-sized planet passing in front of them. From these observations, astronomers are assembling a list of Earth-sized planets that are in orbits that fall within the habitable zone of Sun-like stars. But is it possible we may, one day, be able to detect the presence of life? A much larger telescope, say 10 times more powerful than even Hubble, could detect and study Earth-like planets within 150 light-years of us. It would be able to measure the planet's rotation by recording subtle variations in how the planet reflects light. An Earth-like planet will appear to vary in brightness as continents and oceans rotate in and out of view. Astronomers could also analyze the light reflected off a planet's atmosphere to look for the chemical signatures of life. As far as we know, oxygen can only remain in an atmosphere if it is replenished by biological activity. An oxygen-rich atmosphere would be a strong indicator of life. Nitrous oxide and methane gases could be detectable as other byproducts of life. Scientists will then scrutinize the measurements to rule out all possible non-biological explanations for a chemically imbalanced atmosphere. It is possible that we might never be able to completely rule out exotic planetary environments that mimic the presence of life. The only way to know for sure would be to go there, and that will not be happening anytime soon. Crossing the vast abyss between stars is daunting. One of the fastest human-made crafts ever launched, the Voyager 1 probe, is hurtling out of the solar system at 38,000 miles per hour. That's fast enough to travel from the Earth to the Moon in 6 hours. Even at that speed, Voyager won't cover the distance to the nearest star for 72,000 years. However, we are still only in the horse and buggy days of space travel. With the accelerating advances of science and technology, it might be possible that we could have the technological capability of launching probes to other star systems within a century. As we discover more and more extrasolar planets, it is only natural to ask ourselves, how many of these worlds have life? For now, we can only guess. But from what we've learned about life on Earth, we know that it is opportunistic, tenacious, and resilient. It wouldn't be outside the realm of probability that at least microbes could thrive on some of these distant worlds. Give life a stable enough environment over time, and there could be infinite varieties of it across the galaxy. The search for life on extrasolar planets is really a search for understanding our place in the universe. As we find more planets every year among the myriad stars surrounding us, we understandably ask ourselves, is life on Earth unique? Or is it a natural condition of the universe? And whether or not we are ever able to answer this question, we do know this: abundant or rare, life is special and precious. So we continue to explore the universe, searching for new and exotic worlds. As we do so, we have to ask ourselves one of the most important questions of all. If there is intelligent life on another world, are they, even now, searching for us?